Hey everyone, today we are going to look at binomial expansion. Firstly, we're going to look at Pascal's triangle, then we are going to move on to factorial notation, then binomial expansion, and at last, how to solve binomial problems and estimations. In this chapter, we're looking at two ways of expansion. One is Pascal's triangle, and most importantly, binomial expansion. And you can draw a Pascal's triangle by adding the two numbers above it. So as you can see, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 1 is 3, and so on. And you will always minus 1 from the power to get the row. So like if it's to the power of 3, then it's on the fourth row. And if it's to the power of 2, then it's on the third row, and so on. Let's look at an example in which it asks us to use the Pascal's triangle to find expansion of x plus 2y to the power of 3. So since it's the power of 3, then we know that it's on the fourth row of the Pascal's triangle, in which the numbers are 1, 3, 3, 1, so the coefficients are 1, 3, 3, 1 as well. Then you will write x and 2y behind each coefficient. And you should put a bracket around 2y since there are two terms. And the power of x and the power of 2y have to add together to give us 3. Therefore, we're going to start with 2y to the power of 0, and 2y to the power of 1, 2y to the power of 2, 2y to the power of 3. Then x to the power of 3, x to the power of 2, x to the power of 1, and x to the power of 0. So the first term will be in a decreasing order, and the second term will be in a increasing order. If you do this, your answers will usually be in the form that the question asks. Then you just have to multiply the terms. And since anything to the power of 0 is 1, therefore there is no need to write the second term in the beginning and the first term in the end. But I would usually do it so I don't get confused. And now we're going to look at factorial notation. And factorial notation can be used and to find the entries in Pascal's triangle quickly. You can also use a calculator to calculate the factorial notations. And this is pronounced as n choose r. And you can use this formula if you don't have a calculator or the question asks you to do it without a calculator. And in order to convert the position of a number on a Pascal's triangle into a factorial notation, you can use n minus 1 choose r minus 1. Let's look at an example in which it asks us to calculate the sixth entry in the 10th row of Pascal's triangle. We can use the formula that we just looked at, which is n minus 1 choose r minus 1. Therefore, 10 minus 1 is 9, and 6 minus 1 is 5. And you will type down a calculator, and you get the answer to be 126. A binomial expansion is another way of finding the expansion, except from Pascal's triangle. And the binomial expansion is a plus b to the power of n equals to a to the power of n plus n choose 1 times a to the power of n plus 1b plus n choose 2 a to the power of n minus 2 b squared plus, and it continues until b to the power of n. However, this method only works when n is a natural number, in which n is a member of n. So this means that n has to be a positive integer. This is because it is impossible to choose from a negative amount of n. Alright, let's take a look at an example in which it asks us to use the binomial theorem to find the expansion of 3 minus 2x to the power of 5. And basically we will substitute this into the binomial expansion theorem, which is a plus b to the power of n, which a is 3, b is negative 2x, and n is 5. You can use your calculator to work out each coefficient quickly using the and choose r and power functions on your calculator. Now we're going to look at how to solve binomial problems. You can use the formula to expand a plus b to the power of n by the general term and choose r multiplied by a to the power of n minus r times b to the power of r. You don't really need to remember this, but you can understand it through an example. G of x equals to 1 plus kx to the power of 10, where k is a constant, given that the coefficient of x cubed in the binomial expansion of gx is 15, and it asks us to find the value of k. And you can solve this without using the general term. Just think like this. Kx to the power of what gives us something x to the power of 3. Therefore, it must be to the power of 3. So we know that it's 10 choose 3 times 1 to the power of something times kx to the power of 3. And you know that the power of 1 and the power of kx would add up together to give us 10. So 10 minus 3 is 7, so it's 1 to the power of 7. But we don't really care what 1 is to the power of, because whatever power 1 is, it gives us the same number, which is 1. And in order to find the coefficient of x cubed, we know that it's 10 choose 3 times 1 times k to the power of 3. And we know that 120 k to the power of 3 equals to 15. Then simplify the equation and we get that k equals to a half. And the problem is solved. Approximations can be used to estimate complicated functions. If the value of x is less than 1, then x to the power of n gets smaller as n gets larger. If x is small, you can sometimes ignore large powers of x to approximate a function or estimate a value. Let's look at an example in which we have to find the first 4 terms of the binomial expansion in ascending powers of x and use the expansion to find the value of 0.975 to the power of 10. So what we will do first is to use the binomial expansion and find the first 4 terms. And after we simplified it, we get that it equals to 1 minus 2.5x plus 2.8125x squared minus 1.875x cubed. Then in order to find 975 to the power of 10, we will let 1 minus x over 4 to equal to 0.975. And you will find that 0.975 minus 1 and the result multiplied by negative 4, we get that x equals to 0.1. After that, we'll substitute the value of x equal to 0.1 into the expansion for 1 minus x over 4 to the power of 10 from part A. And we get that 0.975 to the power of 10 will equal to 0.77625 to 4 decimal places. And that marks pretty much the end of chapter 8. And thanks for watching. See you next time.